Chips are in everything, and they've been in short supply since just a few months into the pandemic last year. That's why it's been hard to buy everything from cars to PS5s. Turns out one company makes 24% of all the world's chips and more than 90% of the most advanced ones, the smallest, fastest chips used in today's iPhones, supercomputers, and automotive AI.
Heck, we even have product that's landed on the last Mars launch that are taking pictures of Mars.
Taiwan Semiconductor Manufacturing Company, or TSMC, is not a household name, but it's quietly making chips for every new iPhone, US fighter jets, the highest-end processors, you name it. And now it's investing $100 billion over 3 years to ramp up production amid the shortage.
The combined output of what we're doing is in excess of 12 million wafers a year.
But the world's massive reliance on TSMC may also leave the global chip supply vulnerable to earthquakes, drought, and geopolitical tensions with China.
It's become almost a monopoly at the leading edge, and all of those manufacturing operations, for the most part, are out of Taiwan, Hsinchu. That becomes a matter of national importance for the United States, but not only the United States, but the Western world.
TSMC almost always keeps its production sites closed to US video crews, until now.
The total floor space for this fab is around 2.3 million square foot.
The US was the birthplace of advanced silicon, but for decades now, it's been losing market share to Asia, where 75% of chip production happens now. TSMC is now bringing the world's most advanced chip making back to the US, with a $12 billion fabrication plant, or fab, in the middle of the Arizona desert.
It's going to be, when it gets introduced to production in 2024, the most advanced technology manufactured in the United States.
We got an exclusive tour of the fab site in northern Phoenix to get the truth about the secretive Taiwanese company and why the world's largest contract chip maker is bringing bleeding-edge chip manufacturing back to US soil. When Morris Chang first proposed the idea for TSMC in the mid-'80s, investors were skeptical. Born in China and educated at Harvard, MIT, and Stanford, Chang moved to Taiwan after 25 years at Texas Instruments. There, the government asked him to create a Taiwanese semiconductor company that would become a world leader. His idea? Focus only on manufacturing, what's known now as a pure-play foundry.
When you're just focused on one thing, you do one thing really well.
Rick Cassidy is TSMC's top executive in the US. He's been with the company for 23 years.
The slice we spun out was foundry, and that's what we do. And we put all of our resources into doing that one thing.
Chang bet big on a need that didn't exist in the 80s. When he founded TSMC in 1987, giants like Intel and Texas Instruments took pride in designing and making their own chips. A legendary saying in the industry back then was, "Real men have fabs."
When Morris went out to get funding, he went to many named companies, and they told him, "Morris, your idea won't get off the ground. If you get it off the ground, it can't scale."
But as chips got more complex, making them became an enormous undertaking. Building a fab today takes at least 2 years and $10 billion. It's become nearly impossible for even the biggest chip companies, Intel, NVIDIA, Broadcom, Qualcomm, AMD, to do it all and keep up with the most advanced tech. Intel, for example, still designs and makes its own chips, but it's fallen behind Samsung and TSMC in recent years, even relying on TSMC to make some of its chips.
So if you were a smart designer, you didn't have to have billions of dollars in a fab behind you for the first time with the emergence of TSM.
Now, each major step of chip making is often handled by a separate company. Some, like ARM and MIPS, focus on IP and architecture, providing the core building blocks to design chips. Then there's electronic design automation, EDA companies like Cadence and Synopsys that write the software used to design chips. Only one company, ASML, makes the $180 million extreme ultraviolet light machines required to etch designs into the most advanced chips. And then, of course, there are the wildly successful fabless companies designing the chips. Think Apple, Qualcomm, NVIDIA, and many more. As these fabless companies took off, TSMC found itself on a flywheel, making more and more of the world's chips.
And this has allowed TSM to not only catch up, but in my opinion, surpass Intel to become the world's greatest manufacturing technology on the planet and responsible for becoming one of the top 10 most valuable companies in terms of market cap in the globe.
TSMC was first listed on the Taiwan Stock Exchange in 1994. In 1997, it became the first Taiwan company listed on the New York Stock Exchange. By the 2000s, it had caught up with the 20 or so other companies making the most advanced chips at the time. As the tech kept advancing, more and more fell behind. Until today, only 2 manufacturers remain that can make the most advanced 5nm chips, TSMC and Samsung. In 2013, Apple started relying on TSMC to make its A-series chips for the iPhone as it moved away from reliance on Samsung, a direct competitor in mobile phones. Today, there's a TSMC chip inside every iPhone on the market, and Apple has moved away from Intel too, now relying on TSMC to make the chips inside most Macs.
But they remain sort of in the background. So, Apple gets all the accolades when a new phone comes out.
We let our products speak for themselves. Their success brings all the business that we could ever hope for.
As to why TSMC hasn't allowed U.S. media into its sites before now.
Is part of the secrecy have to do with IP?
Sure, because the IP protection is very important in this industry, not only the TSMC, but also for the other company in the industry.
In 2018, at age 86, Chang retired as chairman of TSMC. His radical, pure-play foundry idea continues to pay off. With the opening of a new fab in Taiwan next year, TSMC is in a race with Samsung to make the world's first 3nm chips, with Intel planning to get there by 2025. Along with cutting-edge 3 and 5nm, TSMC also makes far larger chips for everything from cars to coffee makers. To understand the different kinds of chips and why nanometers matter, let's look at how they're made. Silicon, an abundant element found in rocks and sand, is purified and melted down, then sliced into circular wafers. These wafers are the surface on which chips are built in a grid formation. Each chip on the wafer can have hundreds of tiny layers, each made up of transistors and electrical circuits, which determine what the chip can do. The minuscule circuitry is printed on each layer using lithography, extremely precise rays of light. The smaller the width of the transistor gate, 5nm, 3nm, the more processing power can fit in a given space, with less power needed. The smallest transistors are more than 10,000 times thinner than a human hair.
Most of the chips are probably about the size, a large one, of my thumbnail. On there you might have something like 50 billion plus transistors, and they all have to work. These are parts that are going to be used in lots of different places, CPUs, GPUs, IPUs, etc. They'll be used in smartphones.
Bigger chips are used in most household devices, things like a TV remote or electric toothbrush. Cars often use less advanced 28 to 40nm chips. And all types of chips have been impacted by the shortage. Car makers like GM and Toyota have paused production at some plants. And Apple is cutting its 2021 production targets for the iPhone 13, with orders for the 13 Pro Max delayed by more than a month. Right now, no fab in the US can make 5nm chips, but TSMC is changing that.
The F-35 strike fighter to these consumer products, their customer base is wide. 500 plus companies are their customers in the United States. And so as a byproduct of that, we knew they were going to need to be in the United States at some point.
Chris Camacho of the Greater Phoenix Economic Council got to visit TSMC's fabs in Taiwan during the 5 years he was helping negotiate the deal that brought the project to Arizona.
The robotics, the automation, the mechanization occurring before your eyes. And so you can see how these things not only are so capital intensive, but they're also, their output is so significant.
TSMC is 6 months into building this massive 5nm fab outside Phoenix that will pump out 20,000 wafers per month starting in 2024. The chips from the wafers will end up in iPhones, high-end processors, and much more. Arizona project leader Tony Chen has led 17 other fab construction projects in his 23 years with TSMC.
Actually, this project is designed for 5nm fab. It's a copy from the fab we have in Taiwan.
Just down the road, Intel is in the midst of building 2 new fabs, spending $20 billion. These massive buildings, used to make minuscule chips, have brought some of the world's largest equipment to Arizona.
This is the biggest crane that Man-to-Walk makes. There's only 2 of them in existence, and it's a 2,300-ton crane. Since we've started, our dirt contractor has moved over 3,731,000 cubic yards of dirt. We've also used over 260 million gallons of water.
Indeed, building a fab and making chips takes an incredible amount of water, something that's not easy to find in the middle of the desert. Arizona's biggest water source is groundwater, but deep wells at big farms are using up groundwater faster than it's naturally replenished.
We do need around 4.7 million gallons per day the water to support the production.
TSMC is no stranger to water shortages. Taiwan is facing its worst drought in 56 years, something that TSMC says has not impacted production. In Arizona, TSMC says an on-site water treatment center will recycle up to 90% of water used at the fab.
And then ultimately that water will be re-injected into the aquifer in partnership with the City of Phoenix after reverse osmosis and other technology solutions are provided.
Another challenge of producing the most advanced chips stateside, the current specialists are all in Asia.
TSM's best engineers right now are in Taiwan. They're likely going to stay in Taiwan. The most cutting-edge R&D is going to be done in Taiwan.
To solve this, recruiter Roxana Vega says TSMC is bringing over some of its top experts from Taiwan.
They're seen as subject matter experts in what they do in our fabs over there. And so it'll be a temporary assignment depending 2, maybe 3 years.
TSMC has already sent some 300 new U.S. hires to Taiwan for 12 to 18 months to get up to speed.
And the opportunity to train in our 5-nanometer gigafab in Taiwan is kind of give them that insight of how immense and how state-of-the-art our tools, machinery, and everything is going to be here in Arizona.
Taiwan is not very good when it comes to analog semiconductor design. And by moving to the United States, you'd be able to tap into a much larger number of analog designers.
This diversification is a key reason for TSMC to bring advanced manufacturing to the U.S. And then there's proximity to its huge, fabless customers based in the U.S. like Apple, NVIDIA, and Qualcomm.
If you want more capacity, you have to build more fabs. And that's one of the reasons that we're moving to the U.S. Our customers want us in the U.S. The U.S. government wants us here.
Over 60% of their customer base is still U.S. companies. So some of these companies, like Apple, had hinted that they want their supplier to be closer to home, just in case.
TSMC has 12 fabs, almost all of them in Taiwan and China. They account for nearly 54% of all global foundry revenue. And this heavy reliance on TSMC in Taiwan leaves the world vulnerable to potential slowdowns from earthquakes, the current drought there, or the geopolitical tensions swirling around the US, China, and Taiwan. But some refer to TSMC as Taiwan's silicon shield.
The silicon shield is TSMC is extremely important, and I think people depend on us.
The media paints a very bleak picture of this situation, but I'm actually much more optimistic, in part because of this idea, the semiconductor shield. China, as of right now, needs them for their leading edge manufacturing.
The U.S. also depends heavily on the chips coming out of Taiwan, a key reason the government worked hard to convince TSMC to bring its tech here.
We're not going to have to worry about geopolitical conflict. We're not going to have to worry about another major pandemic. We will have these kind of manufacturing capacities on U.S. soil.
Today, only 12% of the world's semiconductors are made in the U.S. That's down from 37% in 1990.
Back in the days of Bell Labs and the early days of Silicon Valley, we were probably 100%.
Both state and federal officials are eager to entice TSMC to bring advanced silicon back to the country where it first took off.
The state of Arizona has a number of programs, including the Qualified Facilities Tax Credit and the Quality Jobs Tax Credit. That's really an incentive to help lower the cost of operations. In addition to that, the City of Phoenix put together a $200 million infrastructure package that helps TSMC access water and additional infrastructure needed.
The Biden administration has proposed $52 billion in subsidies for chip companies like TSMC to manufacture on U.S. soil. It's been nicknamed the CHIPS Act.
This is infrastructure. So look, we need to build the infrastructure of today, not repair the one of yesterday.
And things like the CHIPS Act are absolutely critical for the success of our country, not only to compete, but to recruit these kind of firms to operate in the US. Otherwise, we're going to be importing chips for the rest of our lifetime.
Over the last 20, 30, 40 years, we've slowly slipped in that manufacturing element, especially as we have seen the decreasing cost in other countries. It's somewhere between 20 to 25% cheaper for American firms to produce their semiconductors outside of the United States.
TSMC's Rick Cassidy took part in discussions that led to the CHIPS Act.
We don't want anything more than to create a level playing field so that it doesn't cost more to make chips in the US than it does in other locations.
Industry reports estimate a $50 billion investment from the U.S. government would enable the construction of 19 new fabs in the U.S. over the next 10 years, more than doubling domestic chip manufacturing capability. As the shortage continues, similar investments are happening around the world. Industry Association SEMI projects 72 new fabs or major expansions will come online by 2024, 10 of them located in North and South America.
I heard more announcements of investments in last 2-3 years than my entire life. Korea will invest $450 billion in next 10 years. EU has announced roughly $150 billion investments. And based on that, we feel that by end of next year, we should start seeing some relief on the chip shortage.
But until then, as demand continues to soar, TSMC is raising chip prices as much as 20%, a cost that could trickle down to the price of consumer electronics.
TSMC has always been able to charge a premium if it was necessary. And most of their customers recognize that if there's a good reason, they're willing to pay for it.
Meanwhile, TSMC will certainly continue investing in ramping up production capacity, including in the U.S., where the 1,100-acre Arizona site certainly has room for a second phase and more.
So we've got a lot of land, and we have the ability to do more there.
It will take time, but it's not just the chip and the foundries, it's going to be the entirety of the supply chain. So it's packaging companies, it's companies that produce the chemicals and the gases required that go into the manufacturing process. So I see this as an entirety of a shift in the semiconductor sector for the United States.
As you can see, we can get into a lot of trouble when everything is in one area alone. So I think it would be a great victory, in fact, to see the United States reverse the declines that we've had over the last few decades.